What is differential leveling? Differential leveling is the process of measuring vertical distances from a known elevation point to determine elevation of unknown points. Differential leveling is a technique used to determine differences in elevation between points that are remote from each other. Differential leveling requires the use of a surveyor's level together with graduated measuring rods.
How to do or how to perform differential leveling. These are the procedures on how to perform differential leveling. The first thing we need to do is to set up the instruments. Begin the process by placing the rod at benchmark point and the tripod in direction of the next point. The rod must be held vertically by the rod person and ensure that the rod is fully extended or in correct length. In placing the tripod, remember to place it in the accurate location between 2 points and make sure to set up the tripod legs firmly. After setting up the instruments, take the backside reading on benchmark. Don't forget to check the automatic level before and after reading the value from the rod to get the first backside. Then add the backside reading to the benchmark point or the elevation to get the height of the instrument. Then after that, don't forget to write every values that we get to the filled notebook. Move the rod to the next point to establish the turning point and take the Foresight reading. Then turn the automatic level towards the rod and don't forget to check it before reading. Read the next value from the rod to get the first Foresight. Then after that, we need to get the turning point elevation. Subtract the Foresight reading from the height of the instrument to get the turning point elevation. Move the instruments and set up again. Move the tripod and place it at convenient location while still in direction of the first turning point. Make sure to set up the instrument correctly to get an accurate value or reading. Then after that, take the backside reading on the turning point. But before that, don't forget to check the automatic level before and after reading. Turn the automatic level towards the rod at the turning point, then read the value from the rod to get the backside on the turning point. Then add the backside reading to the turning point elevation to get the new height of the instrument. After that, move the rod to the next accurate location to establish the new turning point and take the Foresight reading. Turn the automatic level towards the rod and read the value from the rod to get the Foresight reading on the turning point. Then get the turning point elevation by subtracting the Foresight reading from the height of the instrument. Then after that, repeat steps 4 to 6 until we reach the last station and a Foresight is taken. There is no perfection in the survey. That is why we need to check for the error. And there are 3 errors to check. The first error to check is closing the loop. To close the loop, the survey must be done again, or we need to repeat the survey again, but we need to start from the end to the beginning, and the result must be all the same. In this example, there is no mathematical error since it is equal with the value of 0.02. The last error to check is the allowable error of closure. This procedure was established when surveyors realized that it was impossible to survey without some error and perfection is not possible. If there is an error in the survey, we can determine if it is acceptable or allowable error using the equation AE equals K square root M, where AE is allowable error, K is a constant with the range of 0.01 to 1.0, and M is the distance surveyed in miles unit. Most of the surveyors use 0.01 as the actual error and 0.04 or 0.05 as allowable error. When the actual error is greater than the allowable error, the survey is destroyed or unacceptable and the date has excessive error. That's why the survey must be done again. If you have a result of 0.04, then your survey is acceptable since it is greater than the allowable error. Then if you have a result of 0.06, then you need to repeat the survey.
What its terminologies? First is the backside, short for BS. The first step reading taken by the surveyor after leveling instrument is set up and labeled. Backside is generally taken on the point of non-reduced level as on the benchmark or the change point. Next is benchmark. A benchmark is a reference point that helps one calculate something. A benchmark is associated with surveying, can be referred to a permanent mark created at a recognized height which is used as the basis for measuring different altitude of topographical point. Next is the elevation. When the height of the point is vertical distance above or below the surface of a reference plane of the point. When the height of the point is its vertical distance above or below mean sea level as the reference plane, it is called the altitude of the point or the elevation. Next is the foresight. A foresight is a reading taken on the position of a known coordinate. Since a survey progresses from a point of known position to points of unknown position, a foresight is reading looking forward along the line of progress. Next is the term height of instrument. The term height of instrument means the height of the observer's eye when using a hand level when the level rod is next placed on a new point. We can then calculate the elevation of this point. The elevation is calculated by subtracting the foresight rod reading from the height of instrument. A turning point. It is a point on which the elevation is determined in the process of leveling, but which is no longer needed after necessary readings have been taken. A turning point should be located on a firm object whose elevation will not change while moving the instrument set up.
The following are the tools and equipments that are being used in doing a differential leveling. So come and join me and let's get to know them more. So the first equipment that is used is the Philadelphia rod. A Philadelphia rod is a type of leveling rod used by surveyors. The rod is used in leveling procedures to determine elevation and is read using a level. A Philadelphia rod consists of two sections each, measured off in specific gradients. The two sections are arranged side by side and are joined together at one point with a small metal sleeve through which pieces can slide. This allows the Philadelphia rod to be used to greater or lesser extensions, which enables it to be functional over a wide variety of types of terrain and over shorter and longer distances. The second tool or equipment that is being used in conducting a differential leveling is the automatic level. The automatic level is a professional leveling tool that is often used by land surveyors, builders, contractors, and engineers. To use an automatic level, the user turns the leveling screws on the level until the circular bubble vial is centered. This puts the level into the range of the internal compensator. The next tool that is being used is the tripod. A tripod is a device used to support any one of the number of surveying instruments, such as theodolites, total stations, levels, or transits. The tripod consists of a head to which the instrument is attached, the wooden or metal legs that are hinged to the head, and pointed metal shoes on each leg to be pressed or anchored into the ground to achieve a firm setup. The next equipment that is being used is field notebook. The field notebook is a hardback, permanently bound book for recording all survey data documented in the field. On the fly leaf inside the front of the book are instructions to the finder for the return of the book if it is lost. An engineer field notebook is a type of notebook in which the surveyor or other technician or scientists writes down measurements and other technical notes taken in the field.